Okay, I already created a video for this first part of our practice exam, but I want to create another video to take care of the second part. So you need to make sure this entire packet is complete before our final regular exam on Trig. So let's go over this second. It's just like the first part, but it gives you more practice with these Trig concepts. So the first thing you need to make sure you're in the correct mode. So you're only going to need to be in radians for questions 5 and 6. So I'm going to go in order. So I'm just going to check my mode. Right now, by default, I have it to radians, but I need to switch to degrees. So I'm switching to degrees to take care of these first 4 problems because you can see the degree symbol. So here, real easy. They're asking for the tan of a 66-degree angle. Tan is opposite over adjacent. If it's a 66-degree angle, you're going to get a ratio of 2.2460. Okay? Super easy. Try to round correctly to 4 decimal places. That's what the thousandths is. Okay? Now, the secant, you have to realize there's no secant button, but we would use cosines, because cosine of a 73-degree angle is going to measure the ratio of the adjacent side to the hypotenuse, which again is a pretty small number, but then we need to flip this. We're going to have the hypotenuse on top, which is much bigger than the adjacent side, so we expect a bigger ratio. So I'm going to flip that. So here's the button right here underneath the mat. We'll flip that around and put the bigger number on top. So the secant of a 73-degree angle, when you take the hypotenuse divided by the adjacent, is 3.4203. Okay. Here, cosecant, once again, we don't have a cosecant button, but we do have a sine button. So I do the sine of a 65-degree angle. This is the opposite side over the hypotenuse. They're relatively close, so when I flip it, it's just going to be a 1 point something. So flip it, it's going to be a 1.03, and I'll round to a 4. Okay? And then the last one, easy, cosine. I have a cosine button right there, cosine, and I do 15 degrees. It's going to tell me that my adjacent side and my hypotenuse are pretty close to each other. So when I put the adjacent side over the hypotenuse, it comes out to be about a 0.9659. Okay? So now for question 5, since it's not degrees, it's radians, you must hit the mode key, switch over, toggle over, hit enter. So it's now highlighted as radians. Now we're in radian mode. Now it's real easy to type in the sine of pi, so second caret key, and then divided by 36. Okay, so the sine of pi over 36 is going to be a 0.087, and we'll round to a 2. Okay, so again, that's not a big angle, so it should make sense that a small angle would result in a really small ratio, because the opposite side compared to the hypotenuse, opposite side is a lot smaller than the hypotenuse. Okay, and then for secant, we have to use the cosine, so we're going to do the cosine of 11 pi, so there's 11 pi divided by a 36, and you're going to see it's 0.57357, so on, but that's not what I need. I need it flipped, so I hit the x to negative 1, x raised to negative 1, and it's going to tell me it's a 1.7434 ratio. Okay? Should be easy. So now I'm going to switch my calculator back into degree mode for the rest of the test. Okay? So then this next question, this is all about 9-1 and big ideas. You had to come up with these ratios. You can type them in. I am not going to make you rationalize the denominator. If it's an ugly square root, just keep it as the square root of, like, and remember in big ideas you had like the square root of 85. Just leave it like that then. For this problem though, I'm going to make a generic right triangle. I'm going to put my theta right here. And really the only one I told you, so I'll have sine already on your paper. Like, and you need to put the sine. I'll have cosine directly underneath it, and then I'll have tan, and then next to it I'll have the corresponding Sine goes with cosecant. The cosine goes with secant, and tan and cotangent. Okay, and in this case, I am telling you that the secant is a 13 over 25. So the hypotenuse on top of, in this case, the adjacent side. So now I go back to my generic triangle. I have my theta symbol in this lower corner. So now I know my cosine is 12 over 13. So I know if I look here, this is my adjacent side, this is my opposite side, and there's my hypotenuse. So if I'm telling you that the cosine is a 12 over 13, I know the adjacent must be a 12. I know the hypotenuse must be a 13. What I don't know is the opposite side, so that's where it's a right triangle, so I use the Pythagorean theorem. I'm telling you C, so I'm going to type in the C value first, hypotenuse squared, in this case 13 squared minus 12 squared. Okay, you're going to get a 25. Now, obviously, the opposite side is not 25. It's the square root of 25, which everybody should know is a nice 5. Okay, now it should be a no-brainer. You should know SOHCAHTOA, so you know that sine of this angle right here is the opposite side over hypotenuse, which is a 5 over 13. Flip it right away for the cosecant, get an extra point. And then tan is the opposite over the adjacent. And if you flip it, 12 over 5, we now have the cotangent. That's all 6. Okay? So number 8, I'm just having you actually solve for this angle. Now, I could make you tell me what theta is. You can use any of these, and then you could find the calculator would tell you what theta is. But for number 8, since we don't know this angle, I called it angle X, okay? And we want to be in degree mode. So all you have to do, whenever you're looking up an angle, you hit the blue button. So blue button, then the corresponding trig ratio. In this case, it's the sine, and I just type in the ratio. The calculator knows what the angle has to be. If my opposite side is 35 units over 77 units, it's going to tell you, hey, that's about a 27 point, and I'll say 0.4 degree angle. Okay, that's all we're doing. Okay, need you to make sure you're not going to not know how to do that. Okay, so that should be a very easy. Whenever you're finding an angle, that's that blue button. Okay, then for this one, I'm having you solve each triangle. So I would want to see what you only need to use trig one time. Okay, so I don't need trig to find this side because I use the Pythagorean theorem. Okay, so I don't need trig to know little a, but I know little b is a 2, and I know c is the 5. Okay, so I know my hypotenuse. So let's find a right away. So a is basically your 5 squared minus your 2 squared equals your a squared. Okay, so again, a squared plus b squared equals c squared, but if I tell you c, you're going to type that in first. So I know this is a 5. I know that I'm going to subtract a 2 squared, and you're going to get the famous square root of 21, which if you do the square root of 21, and here I would want you to actually tell me it as a decimal, we get about a 4 point, and I tell you to round to tenths. So I'm going to round that to the tenths of 4.6. So it's 4.6. Okay, so now I need to use trig. So bottom line is I didn't tell you either of my angles A or B, so I'm going to need to use trig. And doesn't matter which one, whatever one you decide, I'll find A. So I'm going to circle this A. So my attention is here. That way I know that B is my adjacent side. My hypotenuse is the 5. And then my opposite, which we just found, and I wouldn't really use this one. I wouldn't try to use opposite, only because we just found that and we rounded that number. So to be a little bit more accurate, I want to use a trig ratio involving the adjacent and hypotenuse, and I'm hoping you realize that's the cosine. So I'm going to use the cosine of A. Okay, cosine is defined as the adjacent, which I know that value. I must know that. Since I don't know the angle, I must know the sides. So a 2 and a 5, it's a 2/5. Okay, so now just like number 8, I'm looking for an angle. So second, and then in this case, I hit the cosine button, and then the calculator will look up that angle. So it's about a 66.4 degree angle. Okay, super easy. And now you don't need to know trig to find angle B. I can just take my answer and subtract it. Oops, I did this backwards. Let's delete that. Take 90 minus my answer. And why did that do that? Second negative is answer. And I have a syntax error. So 90 minus 66.4. We're going to see that, and I could have just done that in my head. And it's a 23.6 degree angle. Okay, so Pythagorean theorem, trig to find one of the angles, and then know that complementary angles. Two angles that add up to 90 are complementary. Okay, then the other question, I am telling you the angle. Okay, so we know the angle. I don't need trig to find the other angle. That's 90 minus 53. Find its complement, which we know angle B has to be 37 degrees. Okay, so we can even put 37 degrees in there. So now all I need to know is either B or A. Okay, so it's your choice. We know that this is the hypotenuse. Okay, so I'm going to use this angle here. I'm just going to bring my attention to this. So opposite side is the A, and the adjacent side is the B. Okay, but we know the hypotenuse. So if I'm going to use 53 degrees, I must use a trig ratio involving the hypotenuse. Okay, because if I try to use tan, I don't know the opposite, I don't know the adjacent, I can't solve. But if I use one of the trig ratios with hypotenuse, either the sine or cosine, then I'm going to find one of the sides. Okay, so I'm just going to use the sine. Okay, so I'm going to take the sine of a 53 degree angle. It is the opposite side, so label that A. So again, you can't mix up your A and B. A in this case is going to be my bigger side because it's opposite the bigger angle. And then it's all over 11. Okay, well, that's real easy to solve. So my unknowns up top, then all you need to do is ask the calculator for the sine of a 53 degree angle. It knows what that ratio is, the opposite to the hypotenuse. And then to solve for A, I just undo division by multiplying. Okay, so it's 8 point, and we'll keep it round up to an 8. Okay, so once I know that, I no longer need trig. I could use trig. I could use cosine to find B. Okay, but I'm just going to use the Pythagorean theorem since I know it's my hypotenuse. So my hypotenuse squared is 11, 11 squared, minus that 8.8 that we just found. It's about 43.57, and I'm just going to take the square root of that answer, and I'm going to see it's about 6.6. Okay, so B is 6.6. Okay, so I'll quickly show you that if you use the cosine of a 53 degree angle, it would have been the adjacent over the hypotenuse. If I ask the calculator for the cosine of a 53 degree angle, it's that ratio times 11. You're going to see it would still be an answer of 6.6. Okay, so that's how we solve for the missing parts of a right triangle. Okay, so now we have a word problem. I need to see the diagram. Okay, so we have a 40-foot ladder. That's a really long ladder. So here's my ladder. Label that 40. It's leaning against the building. So here's my building. There's my building. And I'm asking how far away from the building. So here's my building. How far away is the bottom of the ladder? So I need to know what that distance is. Okay, now if I didn't give you more information, that would be impossible to solve. But I'm telling you that the ladder reached a height. So this height right here is 25. Okay, so we're dealing with feet. So feet. So the first thing to find x, I don't need trig. Okay, so I'm just seeing, okay, do you really understand the Pythagorean theorem? And the Pythagorean theorem is your hypotenuse squared minus the leg squared and then take the square root. Okay, so it's going to be about 31.2 feet. And do I tell you what to round? I don't tell you what to round, so I'm actually going to be a little bit more accurate. I'll say 31.22 feet. Okay, that should be very easy. You could have done that in junior high. But now, the harder part of this is where you have to use trig is what is the angle of elevation between the ground and your ladder. So the ground's down here. Here's my angle. Here's my ladder. I want to know that measurement. Okay, so call that theta, call it an x, call it a question mark. I don't care what you call it. But we need to use, from this angle, we need to use the opposite and the hypotenuse, which means you're locked in at sine. Okay, now I guess you could use, if you use this number, but I would use the numbers that were given, because since we had to round this, so it's better to use the sine of some angle is a 25 over 40, and we should know anytime, this goes back to question number 8, if I'm looking up an angle, I hit the blue button, then the corresponding trig ratio, and type in your ratio. Okay, so that's going to be about a 38.68, you could say 0.7 if you wanted to, degree angle. Okay, so make sure you can do a problem like that. Okay, make sense of it. And then here we have the classic, how tall is a tree? So here's my tree. I'll draw a tree. There's my beautiful tree. Okay, and we're told that we're standing 450 feet away. Okay, so 450 feet from the bottom of the tree. Here we are standing, looking up at this tree. And I tell you the angle of elevation. So from the ground to the top of that tree, I tell you this angle is 11.4 degrees. Okay, so what we want to know is how tall is this tree? So really the length of the opposite. So opposite and the adjacent, I don't tell you anything about the hypotenuse. I don't need to know that length of the hypotenuse. All I need to be able to do is figure out the opposite. So, well, that's where the tangent comes in. So the tan of this angle, it's a relatively small angle, but I know that my ratio should be the opposite over the adjacent. Now, well, that's real easy for the calculator to solve. I just type in the tan of my angle, which must be in degree mode, by the way, so we're all in degree mode. We get that ratio, and I just need to undo division by multiplying, and you're going to see that that tree is about 90.7 feet tall. Okay? I need you to realize that that should be easy, okay, with some practice, okay? Compare that to the first practice test, okay? Now, this section should not take long at all. It's just converting from degrees, so I'm giving you degrees, into radians, and then I'm going to have you go the other way, radians to degrees. Okay, so I just put them all together. So the conversion ratio, you have to come into test knowing that 1 pi is 180 degrees. So if I'm converting from degrees to radians, you must realize you are going to divide by 180 and then multiply by pi. Okay, so we're not actually going to use a calculator to multiply by pi, you're just going to write a pi, but you are going to take whatever the degrees that I give you, divide by 180, hit math, enter, enter, and write the fraction, and then the pi. That's how many radians, okay? And then here, doesn't matter if it's a negative number, if it's degrees, I divide by 180, I convert back to a fraction, negative 17 over 9, and then you put the pi. Okay, should be easy. Okay, now the other way, if I give you radians, you're going to multiply by 180 and really divide by pi. But since I'm going to have a pi here, the pi's cancel out. So you will, again, not need to type in pi. There was a couple of big idea assignments where you had to convert, and they didn't have a pi with the problem. So here I have a pi, so I'm just going to type in my fraction, a negative 13 over 18, and I'm simply going to multiply by 180, and I'm going to know that that's And then try to remember your degree symbol, that's a negative 130 degrees, okay? So remember, a negative pi would be a half turn. Well, that's coming up less than a half turn, okay? This, we expect, since this is more than one, it's going to be more than 180 degrees. But again, you just type in your fraction and multiply by 180. And you're going to see, hey, that's 315 degrees. Okay? So hopefully, and you can see right here, look how nice I was there. They're equivalent, so same problem basically. And now here, this section, I just want you to eyeball it up. I'm not going to give you a protractor. A negative, so you always have to start on this positive x-axis. It's called the initial side. So I put my pen here, and since I'm going to rotate in the negative, it's the clockwise direction. So I'm coming around this way, and I'm going to come up shy of 180 degrees. So this would end up in the third quadrant, okay? So just remember your quadrants. If I asked about quadrants on the test, 1, 2, 3, 4, okay? So then a 560, it's a positive angle, so I need to go counterclockwise. I need to do a full rotation, just so you can see. And then if I type in 560 in my calculator, I already completed a 360. I still need to go 200 degrees, so I need to do a 180. And if I do a 180, I still have 20 degrees to go. So I'm going to estimate about where 20 degrees would be. And once again, we're located in the third quadrant. Okay, so, but make sure your angles look like that. I need to see that the direction, the movement of your angle, and I need to see this ray. Okay, so remember, ray starts at the origin and comes out. Okay, so now this page, if I give you radians, now I know this is going to be less than a half turn, but I would convert this by simply type it in your fraction and multiplying it by 180. Again, the pi's cancel out. You're going to see it's a negative 150 degrees. I know it's going to come over here and once again be in the third quadrant. Okay, and then this one, we've seen this before. It's going to be 315. Maybe don't remember seeing this in the previous page, but I'm converting and it's 315 degrees. So what you need to realize is you're going to do a 270, okay, so 315, and if you do a 3/4 turn, you still need to rotate 45 more degrees, which try to be right in the middle there, and you are complete. This would end up in the fourth quadrant, okay, I, B, fourth quadrant, okay? So almost done. You have, if I give you degrees, I want your answers, your coterminals in degrees. If I give you radians, I want your answers in radians, okay? So for coterminal, it's the same position. If I give you a degree, I can add a 360. So if I add a 360, so I'll do plus or minus 360. The one answer, it can be a 7 or a 670. That's a positive. And then if I start with 310 and I subtract a 360, I'm going to see a negative 50. That is the negative coterminal. Okay? In the world of radians, instead of doing 360, you need to know that 360 degrees is equivalent to a 2 pi. So we're going to plus or minus a 2 pi. Now you don't type in the pi in your calculator. Okay? So all you need to do is type in your fraction. Okay? So 3/10. And then I'm going to add a 2, and I'm going to convert that to a fraction. Okay, so it's going to be a 23/10 pi. So don't forget your pi, though. I would have to mark it wrong if you don't put your pi, because it needs pi to be the equivalent and end up in the same location as the original. Okay, so now I can do the same thing. Now I could just subtract 4 here. So if I hit minus 4, I'm going to see I get a negative coterminal. Okay, but that's the same as you on your test typing in your fraction and subtracting it to math, enter, enter. You're going to get negative 17/10. Okay, and then the last two, we just learned this. This is the law of sines. Okay, so this is the last topic. This was a bonus topic. Our book doesn't cover the law of sines, but this is something I want to make sure you're aware that if you go on the trig, it doesn't have to be right triangles. Okay, so you're going to learn others. There's a law of cosines that we won't get to, but we will end with the law of sines, and it's a real easy to set up. We will always put what I'm asking the first thing. Okay, so I'm asking for a side. So first thing, I'm writing that first. So we're going to have all law of sines are, it's a ratio, okay? A ratio, technically a proportion. Two ratios set equal to each other is a proportion where, in this case, we're going to compare the sides to the sine of the corresponding angle. So if I'm trying to find this side, I know that angle. I must be given the angle. It's a 67-degree angle, but I must take the sine of that, okay? And then you must have a side that's given. So I know this side is known. It's 26. And then I must know the opposite angle of that given side. So once again, it's the sine of 88. Okay, so side up top, corresponding angle in the bottom. And then this is super easy to solve. We learn cross multiplying. So if you cross multiply, it's going to be the sine of 88 times A equals, and then I'm just going to ask the calculator for this because it's going to be a decimal. I'm going to type in the sine of 67, let the calculator calculate that, and then multiply by 26. And you're going to get about 23.93. I'm just going to round like that, but keep it stored in your calculator. And then the last move to find what A is, you take that answer that's already stored in your calculator, and you're going to divide by the sine of 88. Okay, again, these calculations would be very hard if you didn't have a calculator, but calculator can do this just as easy if it was a 2A, dividing by 2. So I'm simply going to divide by the sine of 88 degrees, and I'm going to round to tenths. So that technically stays a 9 then. So I would have a 23.9, okay, unit, or in this case, it is centimeters. So I should label that centimeters, okay? I am hoping that makes perfect sense to you, okay? I am hoping. And then the last problem, we are asking for an angle. So when I'm asking for the angle, so my angle is unknown, so I'm going to put my unknown up top. You can't just put a B, okay? So if it's an angle, it's the sine of that unknown angle, so sine of B over its corresponding side. So its corresponding side is a 21, that is known. And then again, you can't mess up the ratio, so in this case, angles go up top, sides go in the bottom. So my angle is 119, that's a big obtuse angle. So I take the sine of a 119 degree angle, and the opposite side of that is a 32, okay? So then this right here, you cross multiply. So I want you to understand that you can cross multiply. Now, another thing in this case, since we're finding the angle, I told you that you can just type in this right-hand side, okay? So the math behind this is we're going to be able to calculate the sine of B by simply multiplying both sides by 21. So again, you could cross multiply, but I think it's easier when it's set up this way to think of just typing in this complete right side and multiplying it by 21. So I'm going to do that. I'm going to type in the sine of 119 degrees. Okay, hit enter. Divide by 32. Again, ugly numbers. Okay, and I'm going to multiply that by 21. Okay, so it's about a 0.57369. So I'm just going to leave that stored in my calculator because this goes back to number 8. It goes back to whenever you're finding an angle, I must hit the blue button. So I'm going to hit the blue button. Oops, I did not want to clear that. I wanted to keep that in, but now I'm going to have to type this number in. So I won't be able to paste this number since I hit clear. Let's see, can I bring it back? I'll just type it in. So second sine, and then normally you would type in your ratio, like if it was number 8, I gave you a fraction. Here it's a decimal. So I'm going to type in 0.573969. And like I said, I would have pasted it if I didn't mistakenly hit clear. And you're going to see it's about a 35.0, I'll say 0 degree angle. And that's how we use the law of sines. Okay? So between the two parts and your practice and doing all the other stuff, you should be more than ready to take our last assessment on trig. Okay, so thanks for watching. Do your best, ask questions. You have plenty of time to get this to really make sense to you. Thanks for watching. Take care.